Good morning, everyone. Engineering Graphics Mini Project. Our topic name is Orthographic Correction. This topic is going to explain by Ninad Rane, that's me, Pauras Raut, Shubham Raut, Saurabh Sharma, Kuldeep Singh, Srimas Matolia, Priyanka Naik, and Rohit Dubey. In orthographic correction, our topic name is projection method. So, let's start from the basics. The line of sight. The line of sight is an imaginary ray of light between an observer's eye and an object. There are two types of LOS, that is line of sight, parallel and converge. In parallel, you can see the lines are parallel, and in perspective projection, you can see the lines are converging at a single point. Projection plane. Projection plane is an imaginary flat plane which the image is created. The image is produced by connecting the points where the line of sight precedes the projection plane. As you can see in the plane projection, the lines are parallel to the plane, and in perspective projection, the lines are converging at a single point. Now we are going to learn orthographic projection. Orthographic projection is a parallel projection technique in which parallel lines of sides are perpendicular to the projection plane. Uh, for example, if we take an object and beam a parallel light to it, the object will form a shadow. That means the rays of light will be completely parallel to the wall. Now, from now to deep dive into this topic, I will hand over to the Porous route so that he can continue further. Porous, you can continue now.
Thank you, Ninad. So, friends, now we are going to see what this orthographic projection does for us. So, this orthographic projection is a technique that can produce either multiple drawing view or axonometric drawing view. So, what this multiple drawing view does for us? This multiple drawing view gives us a view of an object in two-dimensional format, whereas this axonometric drawing view gives us all the three dimensions of the object in one single view. Both these drawing types are used in technical drawing for communication, but here we are mainly going to concentrate on multiple drawing view. So now let us see what are the advantages and disadvantages of this drawing view. So the advantages are it can accurately describe the size and shape of the object. So this multiple drawing view can give us a precise size of the object and the shape of the object which we are considering. The disadvantage is that it requires a lot of practice in writing and reading so that we can analytically calculate and draw the drawing. Now let's take an example. As you can see, here we have a 3D object. So if I have to draw with the help of multiple view drawing, it will look like this. As you can see, you have the front view, then you have the side view. Now you can see here that all the dimensions are accurately represented with the help of multiple view drawing. Okay, now moving further, we are going to now concentrate on planes and views. So what are the different types of planes? There are three different types of plane: horizontal plane, vertical plane, and profile plane. Horizontal plane is a plane of projection in which the top view is projected with the help of multiple view drawing. Now, what is a vertical plane? Vertical plane is a plane of perspective passing through the point of sight and perpendicular to the ground of plane and to the picture. Now, let's see what is a profile plane. Profile plane is a third plane perpendicular to both coordinate planes. The coordinate planes here are vertical and horizontal plane, and hence to the ground line. Now, let's see what are the different types of view. So, there are three views: front view, top view, side view. So front view is a view which is projected on VP, that is vertical plane. Top view is a view which is projected on HP, that is horizontal plane. Whereas the side view is a view which is projected on PP, that is profile plane. Now let let us take an example to get our knowledge about these planes and all. So as you can see in front of us there is a 3D model. With the help of orthographic projection, the 3D model on the paper would look like this. As you can see, to the left top corner, the front view of the object is drawn with the help of multiple view drawing. Then below that, the front view of the object is drawn, and to the bottom right corner, the side view of the object is drawn. As you can see here, the size and shape of the object is accurately described. This is what a multiple view drawing does for us, but it requires practice. To dive deep into this topic, now I hand over the command to Shubham Raut. Over to you, Shubham Raut.
So as you can see on this plane of projection, you can see the observer is looking at the front view of this object. So you can see that how the object will look from the front view to the observer. It will be just a plain 2D shape, but with the lines drawn for the projection and to show the depth. Like here we can see the depth over here. As here we can see the depth over here of this cut, and as well as we can see a hidden line from over here to show the center of this cut. Orthographic projection can be also done by doing the box method. Likewise, you can keep the object in a box and then see uh, how the object will project the lines on the side of the boxes. So here, as you can see, the front view of this object with the lines and the depth of this cut, and above the front view will be the top view, and at the right side of the front view will be right hand side view. If the object is kept in mirrored direction, like the other side, that is the left hand side view is shown, we can also get the left hand side view of the object. So always remember guys that front view and horizontal top view are above or below each other, and the side view is always at the side of the front view.
Hello. So now we are going to see our orthographic object. So it is our first slide. So in this we are going to see this is our object and we are going to make it our front view and top view. Next is glass box approach. In this we will take it our third angle projection. Third slide. In this we will able to see the projection of front view will look like this. And this our last slide, and this in this we will able to see the projection of top view and it will look like this.
Hello guys, myself Kuldeep Singh. Now we will discuss about the glass box and approach. That is visible on the screen, that there are a picture in the screen. It is clearly observed that there is a one object is a place inside the glass box. In that we have to see the projection of point to right side view, in which the red color highlighted part is a front view. Now we will see the next slide. In this we can observe there is an unfold glass box. And the unfolded glass box is just to better understand the different views. This is also same like a previous one. The red color highlighted part is a front view and the green color highlighted part is a top view and the blue color is a right side view. Let's see the next slide. In this there is a two pictures. First is a unfolded glass box and second one is a object in the glass box. In this we can easily compare the unfolded glass box and object in the glass box. Now you all are understand that is the red color highlighted part is a front view and the green color highlighted part is a top view and that blue color highlighted part is a right side view. Now let's see the next slide. In this slide there is a two type of angle projection. First is third angle projection and second one is first angle projection. The first angle projection will be in the first quadrant and the third angle projection will be in the third quadrant for the observer. First angle projection means the object will be in between observer and projection plane. In third angle projection will be the projection plane will be in between the observer and the object. In the third angle projection, the top view at the top and the front view and the right side view are at the bottom of the reference line. And in the first angle projection, the right side view and the front side view are at the top and the top view are at the bottom with the reference line. So here we will now discuss how to observe the right side view and what is the angle of projections. I hope you all are understand all of these topics. Thank you. In next you will see the conventional orthographic view.
Good morning. Myself Srinivas Matholia. My roll number is 62 and I will continue the presentation here on. So now I will explain about the conventional orthographic views. In engineering drawing, there are total 6 principal views. But out of those 6, only 3 are mostly used by us. Those 3 views are known as the conventional or the standard orthographic views, which include the top view, the front view, and the right side view. So, because the other 3 principal views are mirror images and do not add to our knowledge about the object, therefore, the conventional orthographic views, which are the top, front, and the right side view, are mostly used by us. In these conventional orthographic views, the width dimension is aligned between the front and the top view using the vertical projection lines as is clearly shown in the image. The height dimension is aligned between the front and the profile view using the horizontal projection line, which is also clearly shown in the image. Because of the relative positioning of the 3 views, the depth dimension cannot be aligned using projection lines. Instead, the depth dimension is measured in either the top or the right side view. In this slide, we will learn more about the lines. So lines in an engineering drawing signify more than just the geometry of the object, and it is important that while drawing we use the appropriate line type. The various types of lines used are the visible lines, the hidden lines, the center lines, the dimension lines, and the construction lines. Line thickness is also an important part while drawing the problem given to us. For most engineering drawings, we only require two thickness, a thick and a thin line. A thick line is shown in the image. I now point my pointer towards the thick line, and now this is the thin line. A thick continuous line is used for visible edges and outlines. A thin line is used for hatching, leader lines, short center lines, dimensions, and projections. There are also other line styles used to clarify important features. These are the thin chain lines, which are a common feature in engineering drawings used to indicate the center line. Center lines are used to identify the center of a circle or a cylindrical feature or a line of symmetry. The other type is a dashed line, which is used to show important hidden detail, for example, wall thickness and holes. In this slide, we will learn about the precedence of lines. Lines are shown on the views in a drawing in a prescribed order, which is the order is known as the precedence of lines. A solid line, object or continuous, takes precedence over a hidden line, and a hidden line takes precedence over the center line, which have the lowest precedence. The visible lines, the hidden lines, and the cutting plane lines and the center lines are shown in this slide, as we can see. Now in this slide, we will see some examples in examples of visible, hidden and center lines. So we can clearly see the visible lines, the hidden lines which are not exactly viewed, and the center lines. We can see the center line of this circle. These are clearly shown in this image. These are the visible lines and these are the hidden lines.
Dimensioning. A dimension drawing should provide all the information necessary for a finished product or part to be manufactured. An example dimension is shown below. Dimensions are always drawn using continuous thin line. Two projection lines indicate where the dimension starts and finishes. Projection lines do not touch the object and are drawn perpendicular to the element you are dimensioning. All dimensions less than 1 should have a leading 0. That is 35 should have written as 0.35. Orthographic projection is a method of presenting a 3D object on 2D plane using two or more views in orthographic view. Here are some representation of orthographic view. The following object has been classified into three views: the left hand side view, the front view and the top view. The left hand side view is on the top of the XY axis. The left view is on the left of the object when you look at the front from the outside of the object. Likewise, for the front view, the projection view obtained by drawing perpendiculars from all the points on the edges of the part to the plane of the projection. The plane of the projection upon which a front view is projected is called as frontal plane. The top view is drawn below the XY axis plane. Horizontal plane of a projection is the plane onto which the top view of the multi-viewing drawing is projected. Top view is an object shows the width and depth dimension of the object. Here are some examples of representation of orthographic views.
Hello everyone, my name is Rohit Dubey and I am here to explain about some orthographic representation of following figures given in the following slides. In the first slide, in that the given figure has the red and green highlighted part is its right side view, the violet and pink highlighted part is its front view and the blue highlighted part is its top view. The top view is always below the front view due to the first angle projection. In the second slide, the orange highlighted part is its top view, the green highlighted part is its left side view as the side is taken from the right side, and the red highlighted part is its top view. In that way only, the third and fourth slide has its own given front view, left side view, top view, etc. In that way only. I hope you understand the given topic.